Alright, well, my name is Grayson Abner, for those of you that don't know me. Today I'm going to be presenting about kind of a sci-fi topic that might not be as sci-fi as you might think. Time travel, specifically in the movie Interstellar. There's a planet, for those of you that don't know, haven't seen the movie, there's an astronaut. He travels through a black hole in search of another planet that could be habitable since Earth is dying off in the movie. And they come to a planet called Miller's Planet, and time moves at a different rate than it does here on Earth. And we'll get into that a little bit. So what do we know about Miller's Planet? Like I said earlier, time moves differently. I believe it's for every hour that passes on Miller's Planet is 7 years that passes on Earth. So for example, if you spend 4 hours on Miller's Planet, you will have aged 4 hours, but somebody else that wasn't on the planet will have aged 28 years. So what else do we know? We know that gravity is stronger on Miller's Planet. So it's 130% that of Earth, which basically just means that it's 30% stronger. So it's a little bit heavier, not too much stronger though. We also know that it orbits around a black hole. It spins around the black hole. In the movie it said it was moving at 55% the speed of light. So incredibly fast. And then lastly, we know that the black hole is massive. To be specific, I believe the black hole has 1,000,000 times the mass of our sun. So it's a massive, massive body. So let's talk about some of the factors that affect time. So Einstein's theory of relativity covers a lot of ground, but one of the things that it talks about is that time and space are not separate entities. So a lot of people think like, there's mass, there's space, and then there's time. But what the theory of relativity kind of talked about was that things that affect time, or things that affect space, will also affect time. So, for example, gravity. From a lot of theories, the theory of gravity on time dilation states that where gravity is stronger, time moves slower. So for the example of Miller's Planet, we know that gravity is 30% stronger than on Earth's, so time would move a bit slower on that planet. We also know that velocity affects time as well. So the faster an object moves, the slower time passes on that object. And then kind of getting into the theory of like special relativity, when objects get closer to the speed of light, time slows down on them exponentially. And then lastly, mass. When an object has a larger mass, time moves slower on it as well. And as we know from the black hole, 100 million times that of the sun, that is going to have a massive effect on time. And the planet is actually caught, Miller's Planet is caught in the gravity well of the black hole, which basically just means it feels the effects of the black hole but doesn't get sucked in. In the movie it talked about how space and time was getting pulled into the black hole at 99.8% the speed of light. So that's almost near light speed. So basically that just says that's going to have a huge effect on time as well. So in conclusion, it is theoretically possible. Now, I'm not going to even begin to pretend that I understand all of the math that is involved with that. But what I can say is there are actual theories that back up the possibility that a planet like Miller's Planet could potentially exist somewhere in the universe. So it's a really interesting concept. If you haven't seen the movie, I highly recommend it. One of the directors that co-directed the movie is an particle astrophysicist, and so they wanted to make this movie as accurate scientifically as possible. So I would highly recommend it. It's a very interesting topic, and if you'd like to learn more, you can always talk to me afterward. But that's all I got. Thank you very much.